variable, I will store these values of SF into one separate array. So I will create here before starting the loop one empty array for storing the values of SF. Whatever the values are calculated in this part will be stored into this array. And for that, we will use command called append. And similarly, to store the values of small x, because x will be taking values from L, that we also store. So I will use capital X for that variable. And now, so we will use exit if loop and we will store the values of shear force, that is small sf. So capital SF dot append. So we have seen what is the use of append. So I will store the values of small sf and x dot append. So capital X will store the values of small x. So that is from 0 to 10. And finally, we will plot this plt dot plot. On x-axis, we will plot the length, that is capital X, stored values, and y-axis will be shear force. And plt dot show and run it. So you can see, but it looks like something wrong we have done. So it should look like this first. Hmm? Or maybe correct, because here we don't see the 0. It one side should be negative. Something wrong we have done here. Let me check in our program. So conditions SF is equal to R1 minus F, L minus B, right? L minus B into L. Here it should be minus R2 because it is going into negative direction uh, as per standard calculation. So force on the right side should be the negative. So that is one mistake our we have done here. Now run. So now it looks proper, but it is not looking like this. So we will format little bit. So here you can see the line is not straight here on here. So how can we do? Instead of using 101 points, so let's say increase the number of points to 1000, and now you can see line is straight. And we will show how to do the formatting. First, we will write the similar way the bending moment. So in this section, bending moment, what is the bending moment in this section? Bending moment in this section, and finally bending moment in this section. So in three sections, similarly like shear force, we have to write the equations of bending moment, and similarly we have to create one empty array to store the values of this small m. So first I will write here command append small m. So we need to write equations. So in this section, let's say up to this point, bending moment will be just simply R1 into X. So right, so R1 into X. So this is the first section. In second section, it will be this one, R1 into X minus this P1 into X minus A. So this is just simple equation you can find in any book or you can derive. So I won't spend much time on deriving this. R1 into X minus, so R1 is in clockwise, P is in anti-clockwise. So that's why it is minus P1 into X minus A. So this is my second, sorry, it should be in second section, not third section. And in third section, it will be simply R2 into B. So opposite side you can take. No need to write complete sorry, R2 into B. And here I can add two plots. So I need to add a subplot. One is for shear force, another for bending moment diagram, just like uh, here. So first plot, second plot, one after another or you can arrange side by side also, but I will prefer uh, one another one. So here first, how can I do? I will add plt dot figure. I will create one figure whose size, let's say fig size will be equal to, so two figures will be there. So width, total length I will, let's say take 5, and total width, let's say I will take 5. Height is 5. So there will be two figures. That means each figure will take 2.5. And to improve the clarity of the figure, let's say I will use DPI, that is dots per inch, as a 150. We have seen in matplotlib plotting section. And I will add first subplot, that is plt dot subplot. And how can you arrange? Let's say these are the two figures, one after below. So if you see the matrix form, just imagine matrix form. This is a two row, first row, second row, and column is a one. So this is a arrangement of two row and one column type. So first you have to use what are the number of rows, that is two row, one column arrangement, and this is a plot number one, so one. And for bending moment diagram, second subplot, plt dot subplot, arrangement will be the same, two row, one column arrangement, and here plot number two. And here I will add plot bending moment, plt dot plot. On x-axis will be x, that is a complete length, and y-axis will be m, that is bending moment. And let's run. So it is showing me mm, sub he what is shear force diagram and bending moment diagram. It is wrong. That is, it should touch 0. That means we have written something wrong here. So let me check the condition. In this section, we have to use something we have written wrong. Let me check. R2, it should be L minus X, not a B. Because the length, sorry, in this figure, here in this section, it will be varying from L minus X. So in this section, at any point, it will be L minus X, not a B. It will be constant. B will be constant, but L minus X will be varying. And let's see, now it is a proper figure. This is the bending moment. And let's say we want to add some spacing between these two plot. We can add, let's say when you completed first plot, here use command plt dot tight underscore layout. In matplotlib section we have seen, so I am missing L here, plt dot layout tight layout, and pad is equal to, let's say 2. So it will add some spacing. So now you can see, so decrease the DPI to 100 so that we can see the figures properly. Okay. And here now we'll do the little bit formatting. Now add line weight is equal to, or line width is equal to 1. Line width here is also 1. Then color is equal to, let's say I will use black. Now, and line type will be solid line. Here I want to add this kind of mm, hatching. So basically what I have done, so you are seeing right now this kind of line, only this line. You are not able to see hatching. So for that there is a feature or function called fill between. So fill between this x values and y values. So whatever the area is under this x and y axis, we will fill that. So just I will copy this fill between command here, and let's say paste it, fill between. So first I have to mention the values from x axis, from second value from y axis, that is shear force. Now color to that hatching I will add, let's say black, and let's say I will add some transparency to it. Let's say that is command called alpha is equal to, I will make 50% transparent. I will use then hatch. So hatching pattern, let's say this kind of hatching pattern I will use, and let's say run it. Now you can see the area is filled. So similarly you can do it for this bending moment diagram. Now I can reduce the gap between hatching lines. So add one more line here. Now you can see a gap is reduced. Also there are different types of hatching pattern. Let's say vertical line. Now you can see vertical line. Also cross you can use using X. So this kind of cross. Let's say if I add one more X, so it is reducing in the size. So but I will prefer this, so it looks good. Inclined hatching. Sorry, this is not a pattern. This one. Okay. And I can add title to this plot here. Plt dot title as use inverted comma shear force diagram. Then I can add label to the axis. Plt dot y label. So for shear force I will add y label, and x axis label will be common to both. Y label I will add as a shear force in Newton, let's say. Run it, we will see. So shear force in Newton. So title, and I can change the font size also. Here, let's say comma, font size is equal to, let's say 5. So 5 is too small, so use 10. And here I will increase the size of the figure little bit, so it will be good in aesthetic. So let's say shear force diagram, and here I will copy this matter as it is and paste it here. Here you have to change, let's say bending moment M, color, let's say I will use red, hatching same, here use bending moment diagram, font size let's say 10, Y label, change the Y label as bending moment in Newton mm or Newton meter, whatever unit you are using. Plt dot x label, take care of spelling. So if you use single comma or double inverted comma, it doesn't matter, you can use whatever. So length of beam in meter, and finally run it. Now you can see it is formatted properly, but here you can see color is a blue. If you like, you can keep or you can change. So we can copy from here, color is equal to black, comma, red, and line weight is equal to, let's say 1. Here if you want to add line weight, you can add ELW, or sorry, line width, not weight. ELW is not correct, is repeated here. Okay, I have repeated here. Okay, no problem. Okay, so now line looks sharp, and if you want to change the color, you can change, or you can change the transparency. Let's say if I make zero point 0.9, now you can see clearly the difference. So better keep zero point 0.5 or less than 0.5. So this way you can generate shear force and bending moment diagram. So you can take any problem from the book and try to do that. And next I will show one more additional program for from shear force and bending moment diagram. So till that you can practice and these programs you will be first try this program, then take different example, maybe some complicated. Instead of this force, you can take one force at this point as well, overhanging, and try to do that. So thanks for watching and best of luck for further lectures. Thank you.